Thank you. Yep, thanks for the welcome. Welcome everyone to our talk on our paper, Rethinking Trust in Forge-Based Git Security. My name is Aditya. I'm a PhD student at New York University, where I research software supply chain security. And our lab does a lot of really practical work in the space, and like the Linux Foundation and so on. And as part of that, I've also been involved in other projects in the space. Like I've helped lead the development, and I maintain projects like in Toto and the Salsa specification, and of course GitLab. That's very relevant to our talk today. So let's talk about the software supply chain. The software supply chain is a series of steps, people, systems that are involved in producing a piece of software that goes all the way from writing lines of source code to building it to deploying it somewhere. And as this figure shows, right, there are a number of threats we need to be worried about across the software supply chain. But for the purposes of this talk, we're going to focus on the source aspect. Very specifically, we're worried that there are going to be instances where an attacker is able to compromise our source code, maybe insert a backdoor or any other malicious pieces of malicious capabilities into software that then gets built and deployed. And this isn't hypothetical. Like, for example, a few years ago, the PHP project discovered that there were a couple commits that were attributed to the creator of the language and another maintainer that wasn't actually created by them. And upon investigation, they discovered that their Git server had been compromised, and someone had managed to push commits directly there. This doesn't necessarily need to be a case where there's been an infrastructure compromise, right, where like a Git server was compromised or something like that, but it might just be an attacker finds a bug. A number of years ago, a security researcher, luckily in this case, discovered a bug in GitHub's authentication and was able to push a commit into the Ruby on Rails repository. At the time, actually, there was no security program and like a bug bounty program or anything on GitHub's side, and so I think this blog was the first way they really found out, but then they did come up with all of those processes, luckily. And I could really go on. Our paper has a bunch more. There was the Juniper incident. This was the top.gg incident last year. And like I said, our paper has even more, but this is a fairly short talk. So to start thinking about how we'd secure it, let's take a step back and look at what the development workflow looks like when it comes to source code, right? We're talking about Git. It's a distributed version control system. So when you're collaborating with a bunch of developers on a particular piece of software, what ends up happening is all of these developers have their own local copies of a repository, and there's an agreement on, hey, we're going to push all of our changes to this centralized point, and I'm going to fetch changes that the other developers worked on from that point. It's a synchronization point, right? And typically, the centralized point is what we call a forge. It's not just a very simple Git server, but it includes a number of other features, right? Like examples include GitHub, GitLab, Bitbucket. They do a lot more than just host your Git repository. They give you issue trackers. They give you code review systems. They give you other change management features like the ability to create releases, right? And very interestingly, they also do security controls. Like, this tends to be the spot today where if you want to secure this workflow that you have for how code gets contributed into your repository, this tends to be the space where you enable security controls to set guardrails on that process. And these security controls can be bucketed into a few different types, right? You got the policy declaration piece, which is fairly straightforward, as the name suggests. It's hey, who can make changes to the repository, or which parts of the repository need to be protected beyond the baseline, like, hey, this is a really important branch, or maybe this is a release branch or a production branch or something like that. So you have policy declaration. These forges also offer very capable activity tracking features. They keep tabs on all of the actions that are performed on this repository, the different pushes, code review approvals, so on and so forth. There's like an activity log and an audit log on GitHub, for example. And finally, they also perform policy enforcement. When you actually push a change to this centralized point, in addition to keeping tabs on it in the activity tracking piece, they also check that that push was allowed according to the policy that was also configured on these points. Now, as Fish has also highlighted, right? Like, you have the centralized point. There's some natural questions that come about here. Like, you may be wondering, hey, who can edit policy, and who can edit the policy on like the meta level, right? How do you set guardrails on who can edit policy to add other people who can add policy and things like that? And like, can someone just unilaterally make a change, like remove a rule for a moment, make a change to the repository, and then re-enable it and just go completely undetected? With the activity tracking piece, because like the Forge offers all of these very powerful features, but because it's the only one doing it, there's a natural question of what if that log has been tampered with because there's been a compromise of some variety? Can we actually trust it? Like we need these logs, especially to triage and mitigate potential incidents. And there's a very real question of can we trust the contents of these logs? And is the enforcement working properly? That's like another big question. And this isn't really. It might be because there's been a compromise. It might be because there's a bug, right? All software can be buggy. And again, we don't want to have that narrow waist, right? So more formally, this is pulled from our paper. Our threat model really considers that any trusted party, whether it's a maintainer, developer, the Forge itself, may be compromised and misbehave, right? And they may modify the security policies so as to weaken them. They might tamper with the contents of the log, maybe dropping a malicious push altogether, or otherwise subvert the enforcement of policies. So, like the common thread here is across all of these threats, right, is the fundamental trust model itself. Like the common thread here is that everything happens in a somewhat centralized manner. All of this trust is, like in the policy declaration piece, every person who has any ability to declare policy has a tremendous amount of trust placed in them. And the same goes for the activity tracking and the policy enforcement. So if we take a look at that earlier diagram about a typical workflow, like none of the developers can actually reason about the security attributes, like the policies and the activity and so on. All of that is placed entirely onto the Forge here. And so they're just kind of completely taken out of the equation when it comes to security matters. So we asked ourselves, what if we take a distributed approach to address these threats? Because Git is a distributed version control system. Why don't we apply the same principles to the security properties of like that, of like the code contribution process? And so we'd go from like having extremely trusted people who are responsible for policy declaration to, and like a Forge being the only one who can do activity tracking and policy enforcement, to a world where we better pull on the threads of the principles of least privilege and separation of duties, and just spread out this trust a little bit. And that brings me to gittuf. So let's keep going with these examples. Let's consider a scenario where maybe the Forge has been compromised or there's a bug, and therefore it's not able to enforce policy correctly. And an attacker is able to leverage this and is trying to push something to a branch that they should not be able to push to. The Forge says, yep, this looks good, let's go. And all the other developers, they're going to pull it down. And in this centralized trust model, like because they're pulling from the Forge, they just kind of trust it and go ahead, right? Maybe this branch gets built and deployed and so on, and that's really problematic. So I made this point before, right? Git is a distributed version control system. Like if we want to distribute all like this, the policy and the activity pieces of the security controls, what if everyone has the policy and the activity log? Like we already see this with some security adjacent aspects within Git. Like you can sign your Git commits or you can sign your Git tags, and those signatures live in the repository, and everyone who pulls down the contents of a repository can verify those signatures. Why don't we do the same thing with the policy and the activity log? And this is a good segue into like peeling back a layer on how, take a peek at how gittuf works. Gittuf policy is very simple. It's a bunch of cryptographically signed metadata. There's root metadata that establishes why you trust the policy itself. And you have a rule file that says, hey, this part of the repository is protected and can only be modified by these two developers, for example. In this case, I'm going to call them yellow and orange because that's the colors we chose for their keys. So that is quite straightforward. The activity tracking piece is, again, more information that lives in the repository alongside all of your other contents, right? It has a record of pushes. For example, the second entry in that diagram there says Alice pushed the main branch to point to commit A, right? And So yeah, like, and again, this is just more data in the repository that lives in every copy of the repository rather than just in one spot at the forge. So if we go back to that scenario with the addition of the GitHub specific metadata, now the attacker, who should not have been able to push that change whatsoever, still manages to, and the forge is still buggy, but the other developers, when they pull it down, can inspect that push in the activity log, or the RSL, the reference state log, and they can inspect it against the policy and see whether that was allowed. And so they can, determine that, hey, hang on, something went wrong here. And the really interesting thing here is that, like, when we have a bunch of people working on a repository, you only really need one honest client that's performing this continuous policy enforcement to detect something's gone wrong. What if a key is compromised, right? The scenario I just talked about, the attacker was able to push when they should have had no access. But what if, for example, I'm working on a repository and I'm trusted and they manage to compromise my keys and impersonate me? Well, in the current world, like in the current centralized trust model, what we really do here is we try to bump up the number of people that must approve changes to kind of mitigate these, again, single points of trust. And GitHub, in GitHub, we do something similar. So each rule can also be configured with what we call a threshold, so that you can require both yellow and orange to approve a change before it's accepted. So even if the attacker, and the approval is also recorded as, again, more metadata that's stored in the repository and tracked in the activity log, right? What we call an attestation. So even if an attacker manages to get a trusted key and impersonate a trusted developer, the other developers, when they pull it down, they're going to say, hang on, we didn't see that approval. Where's orange? Why did this land, right? And again, detect that something's gone wrong. So GitLab is an open source project. It is released under the Apache 2.0 license. It's part of the Linux Foundation as a sandbox project in the Open Source Security Foundation. It's developed by academics. We're all academics on the paper, but we've had a very strong collaboration with people in the industry who are thinking about the same kinds of problems in the software supply chain security space, and also a bunch of more independent developers who just really enjoy working on these kinds of problems, including a high schooler. It's backwards compatible with the current Git ecosystem. This was a big baseline requirement for us. I don't want to say constraint. We wanted whatever we built to be applicable to existing Git repositories and work with existing Git tooling. We're not going to tell people, hey, you can't use GitHub anymore, you can't use GitLab anymore, right? Because we can't expect them to change the way they develop software altogether to get these properties. And it's being used in a pilot right now at Bloomberg. So this is the repository and for GitHub itself. We also put together a simulation/demo of all of these properties. We submitted it for artifact evaluation, and we did get all 3 badges, which I'm personally very pleased about. I can come back to these slides later if anyone wants to take a picture or something. To close out, we're not done working on GitHub. Great, we got this paper, but there's so much more to do. One of the many things we learned from the pilot at Bloomberg, for example, is that while GitHub works really well within the boundaries of a single repository, if you're an enterprise that has thousands of repositories, you don't want to be managing policies on each one, or that's just a lot of both management overhead, cognitive overhead, and so on. So we're actively working on developing features in GitHub so that the policies can apply across repository boundaries and actually really scale up to thousands or tens of thousands of repositories. If you actually go to our repository right now and look at the open pull request, you're going to see at least half a dozen adding features to that effect. My co-authors leading the effort on bringing a lot of the same properties to read access. Everything I talked about was write access control, but so we also want to see how we can bring a lot of these properties to protect who can read from the repository. And the last one I want to call out, which is also something we cite as a limitation in our paper, is that in an enterprise, you can get everyone to use GitHub maybe, but in the open source world, you can't always expect everyone to use GitHub clients, and we want to improve the experience of working with a repository where some people use GitHub and some do not, and what that world looks like. So thank you. Happy to take any questions, and yeah.
Please go ahead.
Hi, Lars Eckert. I work for Mozilla, so great talk, thank you. And these are real-world problems and real-world issues, as you said. I'm kind of wondering if you could say a little bit more about this deployment you're doing with Bloomberg, because I was listening to the talk and it all sounds great, but the examples you had are obviously very simplistic because you got to talk them through in a slide. So assume like you have like a couple of thousands of developers, and you already said that, you know, at the moment it's one repo and going to multiple ones will be essential. But even if assume you have a mono repo with 1,000 developers, how would that work? How much overhead does it introduce? How much hassle does it introduce into the normal workflow? Do you have any intuition into that?
Yeah, that's a great question. I didn't go into it because those are more considerations we've had to address on how we implement these ideas. And we've tried to do it so that GitLab is kind of developed to be a drop-in replacement on a developer's machine with how they push and pull from a repository, right? So that a lot of this data gets transparently recorded and it doesn't really get in the way of an average developer's experience. And we're also working on integrating some of these features into on-prem Git servers and so on, so that, because again, we can't expect developers to go in and completely change how they work. Hey, you can't do code reviews using, you know, going into the UI and capturing something there and so on. So we've been trying to address those kind of like concerns on the tooling aspect of it. We also do have some numbers in the paper about how much overhead it adds, because I think that was another question you had. And on a per push basis, it was in the order of like 0.0 something seconds. But yeah.
So one is runtime overhead, and it's great to hear that that's very little. I'm also like just worried about like developer time. Like how often will this like flag something that ends up being like a false positive, and somebody has to like spend time figuring out like what happened here and why isn't this going through? Where at the moment they don't have to spend that time, but also they also don't have the security, right? So I'm trying to see like get a feel for it. Like how much hassle would it be to adopt something like that if you're running like a large scale project? That's basically the high level question.
Gotcha. We're still working on that as part of the pilot, right? Like we're capturing all of this information, and I also can't really speak to some of this.
That's fair.
Yeah, but like if you catch me after one-on-one, I'm also happy to like chat about some of this.
Yeah, and I don't want to give you a hard time. This is great work, and I'm really interested. That's why I'm asking the questions. Thank you.
Yep.
Hello, thank you very much for your presentation. I had a question regarding your example when you mentioned that a key could get compromised, and you didn't seem to mention anything about revocating keys or expiring them.
Yeah.
Have you guys thought about doing anything like that? How would that work out?
Oh, yeah. So that was really just to, you know, for the time constraints. GitHub policy can be updated in band. So what you'd really do is revoke that key in GitHub policy, because the policy says, hey, these are the trusted keys, and now you have this issue. You revoke that key and it's not trusted anymore. Like if we go back to one of those diagrams, you'll see that the activity log also tracks the policy itself, because policy can change, right? And so you revoke the key and henceforth it's not trusted anymore. And there's also a recovery mechanism, because maybe someone who compromised the key made a change that now needs to be undone, and like, you know, it shouldn't be trusted anymore, even though it looked okay at the time, and so on. All of this is covered in our paper, but I try to keep it at a higher level for the talk. Good question.
Awesome. Thank you very much.
Cool. Thanks, everyone.